Hi, chemistry. I wanted to come on and I wanted to show you a little bit about the steps and how you would maybe go about solving a stoichiometry problem. Okay, so I have it labeled out here in 4 separate steps. I'm going to help you by going through each step and show you what I do to figure out the actual problem. Okay? So you're normally given an equation to start off with. Okay? And so starting off with step 1 is you need to look to see if your equation is balanced. If it is, go to step 2. And if it is not, you need to balance it. This is really important. Okay, so we'll start off. I'll use my color brown. So here we go. So if we look at our equation here, we can see we have 2 borons, 6 hydrogens, and 2 oxygens on this side. On the other side, we have 1 boron, 3 hydrogen, which is broken up into 1 plus 2. And then our oxygen is also 3, broken up instead into 2 plus 1. Okay. If we take a look at that, we notice definitely that our numbers aren't the same, so this equation is not balanced. We have to balance it, okay? So hopefully you remember how to do that. Otherwise, I can go through it here step by step for you, okay? So remember, you have to get these numbers to be the same at the end, and the way that you do that is adding numbers here. You cannot take any numbers away, nor can you change any of these subscript or little numbers. So first off, what I would look at is probably the easiest one, which is B. So we'll notice that we have 2 here and 1 here. Easiest way to change that is to add 1 more and get it to 2. So that would be a 2 there. We just have to see how that changes this. So we have 2 hydrogen there now, so 2 here. So we've changed to 4 hydrogen overall. And for oxygen, it's changed this 2 into 4. So we now have 5. Okay. So that's still a little bit of a problem, especially since this is a 2, which means our oxygen here can only be, what do I want to say? It can only be even numbers, so it can't be a 5. So what we can do is try and change this number into a even number. And instead of changing this, let's change this number here, which is like change this formula, like add here, because if we change that there, we can change this one maybe into an even number. So if we just make this into 2, it changes this into a 2, so now we have 6 total. And our H's, this H here changes to a 4, and now we have a total of 6 here as well. B's look good. H's look good. Our O's are 6. But thankfully, O is by itself, and we can just change that to get 6. So what times 2 is 6? That should be 3. to change that into 6. 2, 2, 6, 6, 6, 6 would be a 1. This is our formula is now balanced. Woohoo! So we had to balance this, and we did. So this is going to be our numbers that we put into our balance formula from here on out. Okay. So once we've done that, then we go to step 2. Step 2, look to see what your equation is telling you. So it's telling us that in our equation, we take these two reactants. We need 1 molecule of B2H6 added to 3 molecules of oxygen gas, and they react together to give us 2 molecules of HBO2 and 2 molecules of water. Okay? So that's one thing that you know. Yet another thing that you know is that these numbers can also equal to the number of moles that you need. So if 1 mole, so in this reaction we need 1 mole of this and 1 mole of, 3 moles of this, and once they react together, we get 2 moles of this and 2 moles of that. Okay? And when we do this, it is a complete conversion over. We won't have any leftover stuff. Okay? This is going to be a complete reaction where there's no loss at all, like in a perfect world. So I'm going to write a couple things down here. So 1 of you need 1 mole of okay? That's what your equation is telling you. Okay, that's what this is saying. You can also look at your numbers here, which is important. So in order for you to go from one to another, you can see a increase or like the numbers that they are. So for instance, if we look at, say, the ratio of this molecule or this, reactant compared to this product, you'll notice it's a 1-to-2 ratio. So no matter what, in order to, if you have this reaction, no matter, as long as this is in proportion, say you had 2 of these and you had 6 of these, you're going to get a ratio that's still going to be reflected on the other side. So if this is a 1-to-2 and you increase the numbers here by 2, you'll get twice the amount of product. So if this was a 2 and this was a 6, you would get 4 of these and 4 of these. Okay? It's going to be related and in proportion. Okay? So keep that in mind. let's see. And that also means that if we want to make this whole entire reaction possible and we double this and we still want it to be complete, we'd have to double this too. Okay? Okay. Moving on. So I'm going to copy over my numbers here. So we're done with step 2. Moving to step 3. Look at your questions that you've been given about the equation and understand what you need and what you have. You can write notes about this up here in your equation, like right below it if you need to. So, your questions. The first question that's given about this is, what is the mass of oxygen gas that will be needed to burn this 36.1 grams of dibutane hexahydride completely? So this is if we did a complete burn and we had no leftovers in the reactant side. Okay. You need to look at that question and ask yourself, what do you need to find and what it is that you have already been given. So hopefully you should be able to see that the thing that you're looking for, what you need to find, is the mass of O2. Okay? And the mass of O2, you can see, is split up into 2 separate places. Okay? So, and that's talking about, that's talking about just O2. Don't get confused with it being here. Like, I know you have oxygen here and here, but we're talking specifically about this. How much are we going to need here so that this and this get used up all the way? Okay? The thing that you need or have that you've been given, we've been given a certain amount of dibutane hexahydride to get rid of. Okay? That's all we have. We can't take any away. We can't add any. We have to use all of it. Okay? So you need, and you'll notice I have the word mass here. So hopefully you know that you need grams of this. Okay? Because it's in grams over here. So you need an amount of O2 that reacts with your B2H6 completely. And the thing that you have already is an amount of B2H6. But that you also have something else along with that. You also have what we just talked about up here and step 2, which is the ratio of the two. So you also have a ratio for a complete burn or a complete reaction to happen. Okay? Which is a 1:3 ratio, where 1 is for the B2H6 and the 3 is the O2. Okay? So that's what you need for the first question. And you can even mark that on here on your paper. I'm going to use pencil. So we're looking for, so we need to know this in grams. And we have this in grams already, which is 36.1 grams. And we're trying to figure out what we need for that, knowing that we have a 1:3 ratio, meaning that whatever we have over here to help us convert, whatever we find on this side has to be times by 3 to get our grams of oxygen over here. Okay? Next, how many moles of water are produced from 19.2 grams of your dibutane hexahydride? Okay? So if you read that again, how many moles of water are produced from 19.2 grams of I keep saying butane. It's diboron. Diboron hexahydride. So first of all, you should realize that the thing that we need to find is an amount of moles of water. If we look here, the only place we have water is over here on the product side. So we need to find how many moles of H2O. Okay, and so this is, again, in a complete system where everything over here is used. Okay, and then hopefully you realize the thing that we have is the 19.2 grams of diboron hexahydride. Okay. Okay, so that's one thing we know. We have, we have an amount of that B2H6, which is 19.2 grams. Okay, we also know something else based on what we just talked about with ratios up here. We know that in order to, in a perfect system, in order to get rid of and burn these completely, when we do that, we get 2 moles of water out of it, which means that there is a 1:2 ratio here between the two. And in order for us to, use it, like get the amount here or like use up all here, it needs to be times by 2 over here. So the ratio of B2H6 to H2O is a 1:2 ratio. All right. And so I'm going to try and mark that out here as best as I can, which is knowing for that one, if we have 19.2 grams of that, then we need to find out, we need moles over here, right? So what's going to help us here is maybe not grams anymore. Might help us if we had some sort of thing that was comparable to it, which is the moles that it is. And then using our ratio of 1 to 2, we can convert that to moles of water. Okay, this may seem a little complicated right now, but I promise it's all trying to come together here. So we know this. So now what you have to do in step 4 is connect what you have and what you know. So what you've just like figured out in your steps 2 and 3, connect them together and answer up here. Okay, and then you can answer your questions down here as well. So I'm gonna again bring my numbers over, 3, 2, and 2. Okay, and I'm gonna copy my stuff from here over. So for A here, know that we have 36.1 grams there, and a 1 to 3 ratio between these two. So whatever we have over here is times by 3 to get our answer up here. And we need this in grams. So the first thing for that one, what I'm going to look at, I'm going to solve A here separate here for us, is something that's going to help us a lot is knowing that the moles are going to help us out. So we need to look at this and figure out how many moles this is, and then equate it to the amount of moles, like times that mole by 3. Like the amount here, so we get a proper ratio. So for example, so boron, diboron hexahydride, so we have boron, let's find the molar mass of that. So boron, it says, is 10.8 grams per mole. We have 2 of those. And hydrogen obviously is 1 gram per mole, and we have 6 of those. So if we add those together, 10.8 times 2 is 21.6. And then this is obviously 6. So you add those together to get your total molar mass, which is going to be 27.6 grams per mole. So we know that there's 27.6 grams per mole here for the molar mass of this here. Okay. Knowing that, we can actually find how many moles this is, and then use that to get a proper ratio here. So 36.1, and in order to do that, you have to take 36.1 and divide it by your total amount. So 36.1 divided by 27.6. And you get 1.3 moles. So we have 1.3 moles here. And remember we said it's a 1 to 3 ratio. So whatever we get here, we have to times it by 3. So if we do that, times by 3, because we have to keep this 1 to 3 ratio. If we have 1.3 moles of this, we have to have 3.9 moles here. I'm just going to round it to 3.92. And now we can take that and convert that into grams up here. And so the molar mass of oxygen gas is, so each oxygen is 16 grams. And we have 2 of them. So that should get us 32 grams per mole. Right? And then we can take that and times it by 3.92 and get our answer, which is about 125.6 grams. Now some of you are going, but if I take 36.1 times it by 3, I get 108.3. Now, this is why the reason why we can't take this number and times it by 3 is because this number is based on the mass. You need to understand that this chemical and O2 gas, they are not the same element and they're not the same molar mass. You need to have a different amount of this. 1 mole of this is a different size than 1 mole of this. So in order to make the grams here jive, you need to convert this into moles, and from moles here, find the ratio in moles here, and come back up. Okay? So, again, I know it may look confusing, but we needed to just understand the ratio here to here. It's 1 to 3, and that's molar ratio, not gram ratio. Okay? So, the mass of O2 that we need, which is 3 moles of it, is going to be 125.6 grams. Okay? All right. So that was part A. I'm going to erase our molar mass since we already have it down here. I'll use it for over here. So our second question says, how many moles of water are produced from 19.2 grams of our diboron hexahydride? So what you have to do for that one, again, remember we have to know that we have 19.2 grams of that over here. And we talked about changing it into a mole because then we have something that we know the amount here to get our proper ratio here. So if we do that real quick, we already know the molar mass of this up here. So if we take that and find out how many moles it is by going 19.2 grams divided by 27.6 grams per mole, your grams cancel out to leave just moles to go to the end. And so let's calculate that. 19.2 divided by 27.6 is 0.695. I'm going to round that roughly to 0.7 moles. So we have 0.7 moles. Okay. And in order to get our ratio, our 1-to-2 ratio of this to water, whatever we have here needs to be times by 2. And so if we take 0.7 moles and times it by 2, we get 1.4 moles of water that is needed. Okay, and that's where we need to stop because it asked for moles. If it had asked you for grams of water, you could go even further, just like we did down here, and convert those moles into grams. But we don't need to since it asked for moles, so all this is 1.4 moles. Forgive me for using MOLS sometimes. That's just what I use sometimes in chemistry in college. So now we've answered both of our questions and we're done. And again, it's complicated. I know it is. It looks like it, but it really isn't. It's simply a step-by-step process talking about what you need to, what you have, what your ratios are, and how you can convert those ratios that you have, and convert what you have using those ratios into the correct numbers, whether it's from grams to grams or from grams to moles, or even you can go into molecules too. Based on what we've learned already, you can do that because we've practiced going and converting between all three of these: moles, grams, and molecules. Okay? This one was a little bit long. I'm going to find another one to do, not in the same video. I'm going to find another one in another video and come out with that so I can help you with this again, do more practice with you. I talked about the mole stuff not going away anytime soon. This stuff ain't going anywhere anytime soon either. I'm going to be practicing this stuff quite thoroughly. Ooh, excuse me, it's been a long day. So that you can get the hang of this. Okay? All right, I'm going to stop there and find another example for you, and I'll see you all in the next episode. Or at least in the next help video. Bye, everybody.